Okay, today we're going over fire control. Be there next chapter. Our actions of the initial fire attack team will determine the success or failure of our fire control operation. An uncoordinated attack can result in a small fire developing into a major loss and increase the dangers to personnel and to the public. Firefighter safety in any fire control situation must always be the first priority. Any potentially hazardous situation, personnel must work in teams. Firefighters must constantly be alert to any potential hazardous conditions, such as a possible building collapse, fire behind, below, or above attack teams, holes, weakened floors, and other fall hazards, overhead loads on weakened supports, hazardous materials, backdraft or flashover potential, utility hazards, overexertion, and panic and confusion. Size up must be performed in any emergency situation. The size up is the mental evaluation of the fire in which determines the course of action. It must be a continuous, ongoing process as the situation changes. Proper size up is based on the following: the known facts of the incident, such as time of the emergency, location of the emergency, nature of the emergency, life hazards, exposures, property involvement, and different weather conditions. It's also based on what may probably happen, potential changes in the life hazard, the routes of the fire extension, the probability of explosion or a collapse, and potential weather changes. It's based on the fire department's own situation, such as personnel and equipment available and en route, what additional assistance is en route or can be made available, how much water supply is available, and what actions have already been taken. Fire attack must be coordinated with rescue operations, forcible entry operations, ventilation ops, and utility controls. Our life safety is always the first and most important tactical priority. Includes the lives of firefighters, those in danger, other emergency responders, and spectators. Incident stabilization involves stopping the emergency from getting worse through rescues and extinguishment. The third tactical priority is property conservation. Minimizing further damage created by suppression, using salvage operations to protect property, preventing a fire from reigniting after extinguishment. An offensive strategy usually involves using resources for interior fire operations to accomplish the incident priorities. Considerations which determine the tactics in an offensive strategy are the value, life and safety hazards at the scene, savable lives, or salvageable property. The time to accomplish the tactics, potential for collapse, and potential for changes in the fire conditions. And our size, the tactical flow rates needed to control the fire, the available resources, and our fire conditions. An offensive strategy objectives include rescue and/or the fire extinguishment. Rescue and extinguishment may occur simultaneously. Defensive strategy may be used when no threat to the occupant life exists, occupants are not savable, property is not salvageable, adequate resources are not available for an offensive strategy, there is danger of collapse, an offensive attack would endanger firefighters because of hazardous conditions. Intended to isolate or stabilize the incident and prevent further expansion. Usually an exterior operation to save exposures while sacrificing a building. Defensive operations may be used when the amount of fire is greater than the ability of available resources to control it due to the lack of personnel, the lack of water supply, or inability to provide adequate fire flow, lack of Defensive operations may be used when the structural deterioration or interior operations are unsafe, the risk of personnel outweighs the benefit, wind conditions prohibit safe entry from high temperature flow paths, when transitions between offensive and defensive attack can occur at any time. Defensive to offensive. First arriving units may use a defensive strategy until additional resources arrive, the fire is reduced or extinguished to safe levels, or additional personnel arrive to provide for a safe two-in, two attack. Offensive to defensive. If a rapid change in the situation occurs, the incident commander may decide to change from an offensive to a defensive operation. When this change occurs, the incident commander must communicate the change to all personnel. Personnel Accountability Report, or PAR, is conducted to ensure safety. Some units may remain in place to protect the withdrawal of other units. Hose lines should not be abandoned unless absolutely necessary. And the Rapid Intervention Crews, or RIT, must be ready to help during the transition. During the offensive to defensive transition, firefighters must maintain situational awareness, know the department's evacuation signal, monitor the radio for further orders, remain calm and follow orders, and stay with your team. Use the hose lines as a guide to exit. Have the hose line ready to provide protection. Evacuate as quickly and safely as possible. Respond to PAR. And know the procedures for different strategies. For structural firefighting, forcible entry and ventilation must be coordinated with the advance of the attack team. Entry teams must carry any equipment which they may need to force entry, check for fire extension, and make an emergency exit. Entry teams must also be in contact with exterior teams to prevent opposing fire attacks and in case of a sudden endangering situation. The size of the hose stream and hose line depends on the fire load and the materials involved, volume of water needed, stream reach, personnel available to handle the line, mobility requirements, speed of deployment, and potential fire spread. The minimum size stream for any structural fire should be a 1.5 or 1 3/4 inch hose. Our hose stream characteristics: a 1.5 or 1 3/4 inch hose line, typically between 40 to 175 GPM, for 1 to 3 room fire involvement, used for a quick attack, when personnel are limited, and for rapid relocation of lines. Characteristics of a 2.5 or 3 inch line are for 1 floor or more involvement, when size and intensity of fire is beyond the reach and control of 1.5 inch or 1 3/4 inch lines, when there is enough water and personnel, when exposure protection requires larger volumes of water. Are master streams for well-involved large structures, when size and intensity of fire is beyond reach and control of hand lines, when water supply is ample, when there is sufficient pumping capacity, and when interior attacks are no longer feasible. A backup hose line must always be in place with every primary attack hose line to protect the attack team from extreme fire behavior, protect the means of egress for the attack team, provide additional suppression in the event if the fire increases. The backup hose line should be at least the same size as the attack hose line. A fog nozzle is preferred for the greatest protection for both teams. If adequate ventilation can be provided ahead of the fire attack, a narrow fog pattern can be used for fire attack. It allows the smoke, heat, and steam to vent and helps maintain thermal layering. The stream can be swept across the ceiling to break the water into smaller drops to rain down on the fire. If ventilation is not provided, a straight stream directed at the base of the fire should be used. Promotes visibility and less steam production. Does not push heat, smoke, and fire. Uses less water. Provides greater penetration, reach, and faster knockdown. The thermal layering can be upset with either fog or straight streams. However, less disturbance will occur with straight streams. Nozzles should not be open until the fire is located. Applying water into smoke decreases visibility and increases water damage. Upsetting the thermal balance can cause steam burns. The incident commander should decide where the entry will be made for the interior fire attack based on our wind direction and speed, our building conditions, initial fire location, occupant locations, and our exposures. Before making entry, firefighters must consider fire behavior indicators, the crew's assignment, potential emergency escape routes, forcible entry requirements, and hazards such as electrical wires and structural stability. Before making entry, must also consider all communications equipment is functioning properly, our SCBA cylinders are full and properly operating, our pass devices are on and functioning, and all team members are ready. Entry teams must carry any equipment which they may need to force entry, check for fire extinction, and make an emergency exit. Entry teams must also be in contact with exterior teams to prevent opposing fire attacks in case of a sudden endangering situation. Before entering the fire area, air must be bled from the nozzle by opening the nozzle slightly. The nozzle pattern should also be checked before. Crew should wait until the order is given to advance into a structure. Personnel should be to one side of the entrance, and they should stay low to allow heated gases and fire to exit over their heads. Traditionally, fires have been approached and attacked from the unburned portion of the building. These tactics were based on the belief that fire streams push fire into unburned. Underwriters Laboratories and National Institute of Science and Technology tests have shown that fire streams do not push fire. Fire streams simply change the flow path, the directional airflow, thus giving us the perception that the nozzle is pushing the fire. Opening a wide fog stream changes the flow path or plugs to allow a flow path by entraining air. As the fire reacts to the added air, the burning moving overhead increases and the conditions could deteriorate quickly. Today's tactics show that applying water to the fire as quickly as possible can make conditions in the entire structure better, regardless of where it is emitting from. Fire attacks should be done in the same direction as the wind because wind can cause unpredictable changes in the fire behavior. Direct fire attack. Application of water directly at the base of a fire with a straight stream and short burst of water, or penciling. Another technique is to cool hot surfaces by applying water over the hot materials, or painting. Avoid upsetting thermal balance by limiting water use. And shut the line down when the fire darkens down. Indirect fire attack, used when firefighters are unable to enter the building because of intense fire. Should not be used when there may be trapped victims or when fire spread cannot be contained. Water is directed at ceiling from outside and played back and forth. Once the fire has darkened and the area ventilated, the line should be advanced for a direct attack. A combination attack combines playing stream off the ceiling to cool the hot gas layer and applying directly to the burning materials. You start with penciling in short bursts. and the nozzle is moved in a T, Z, or O pattern with a straight stream with its edge reaching ceiling, walls, and floor. Types of fire attacks. Gas cooling reduces the hazard from the hot gas layer. Effective with a shielded fire where water cannot reach the burning material. Cooling the hot gas layer slows the transfer of heat to other combustibles. To cool the hot gas layer, set the nozzle pattern between a 40 degree and 60 degree fog. Direct it upward to the hot gas layer. Open and close the nozzle quickly in 1 to 2 second pulses. When droplets fall from the gas layer, stop spraying. Continued water application will upset the thermobalance and create steam, and will cause steam burns. Repeat the technique while the attacker advances under the gas layer. High-rise building fires require a greater number of firefighters. Equipment has to be taken to the level where needed. Large-scale evacuations may be needed, and the operation may take significant time. In addition to attacking the fire directly, floors above should be checked for extension. Staging of personnel and equipment is normally 2 floors before the fire floor. Elevators should not be relied on to get to the fire floor. If the structure has a standpipe system, the standpipe's location will determine the method of fire attack. If standpipe connections are in protected stairways, hose lines should be connected on the fire floor and the attack made on that level. Attic fires. Where possible, operate from the floor below the attic. Roof ventilation will be necessary. The ceiling should be pulled and the fire attacked from below. Do not use ventilation holes for attack from above the attic. Fires below grade and structures. Structure fires below grade create extremely dangerous conditions. Residential basements may be used as living quarters, utility and storage spaces, garages, or storm shelters. They may be unfinished with exposed structural members, combustible ductwork, open spaces and unprotected openings, unprotected lightweight construction materials. A thermal imaging camera can be used on the floor above the fire to locate the seat of the fire. It will not always determine if the floor is safe for personnel to be on, though, so keep this in mind. If it is determined that the floor over the basement is safe, a hole can be cut in the floor and a cellar nozzle inserted into the basement. If the thermal imager or cellar nozzle is not available, firefighters may have to go downstairs to attack the fire in extremely punishing conditions. Stairs become chimneys for smoke and superheated gases from the basement. Clear upper floors of smoke, and ventilate at a point away from the stairs to be used. If proper ventilation is done away from the stairs, firefighters may use a wide fog pattern when descending down the stairs. Basement windows should be open opposite the stairway down. If no windows are available, a ventilation opening can be cut on the ground level floor near a window, and a smoke ejector can be placed in the window to vent the smoke and heat from the basement to the outside. Avenues of vertical fire spread should be protected. The stairs, walls, and shafts. A horizontal extension to adjoining buildings should be monitored as well. Commercial basements may be designed to support machinery and upper stories. In Type 3 construction, first floor joist may be exposed wood joists. In newer construction, the floors may be exposed concrete panels or metal joists. And in some buildings, the subfloors may be as mechanical spaces or even parking garages. Metal floor supports may fail when exposed to fire. Unprotected steel girders can elongate when exposed to 1,000 degrees Fahrenheit or more. And heavy objects of floors above the fire can speed the failure of supports. The tactics used in commercial basement fire should be based on a risk-benefit analysis for the safety of personnel, the locations of standpipe connections, ventilation flow paths, and the amount of breathing air needed for extended below ground operations. Exposures can be structures or any other property where a fire could spread. Interior exposure protection may involve closing doors or openings between the fire and exposed area, using tactical ventilation to make sure smoke and movement is limited, placing fire streams between involved and uninvolved areas, Exterior exposure protection may involve evacuating people in the path of the fire, relocating parked vehicles, using equipment to move piled storage, and moving fire apparatus if in danger from fire. Exterior exposure protection may involve using fire streams to protect an exposure. Direct application of water on the exposure limits the effect of radiant heat. Direct application is more effective than using a water curtain unless the water curtain spray is a sufficient dense. Fire personnel must be able to control the flow of electricity into structures where emergency operations are underway. In some situations, power may be needed to operate lighting, HVAC equipment, or fire pumps. If fire involves only one area of a building, other areas may be left energized. If the building is damaged to a point where electrical hazards are created, power should be turned off at the main electrical panel. Firefighters should never attempt to remove electric meters to shut off the power. An explosive arc can occur if the meter is improperly removed, causing injury or death. In some occupancies, removing the electric meter does not stop the flow of electricity. The meter may be only there to measure usage, and removal will not disconnect power. In some installations, backup generators may start when the utility power is shut down. Above-ground power lines connect the power to a structure through a weatherhead and service mast on the building. The electric meter is usually mounted at the base of the service mast. A service mast may become electrified from a short circuit in the electric panel or within the mast itself. With underground power lines, several large steel boxes containing transformers will be located at ground level around a neighborhood. The power typically enters a building through a pipe which enters the bottom of the electrical panel. Firefighters must not open or tamper with a transformer box or under. Firefighters should also check for any alternative power sources at any emergency. High-end solar panels generate 200 watts of DC current at 18 volts, or about 11 amps. Panels have shut-off switches on the inverter and on the electric meter. Solar panels generate current whenever there is a light source and are always energized. You should also check for alternative power sources at any emergency. If fuel power generators, which usually are for backup power in case the commercial power fails, it can be controlled by shutting off the generator. Natural gas is comprised of mostly methane with ethane, propane, butane, and pentane gas added. It's odorless and colorless. Utility companies add mercaptan as an odorant for leak detection. That's the smell that we get when we smell gas. No odorant is added to gas moved through cross-country pipelines. Natural gas pressures can be up to 1,000 psi in pipelines and about 50 psi in distribution piping. Approximately a quarter psi at the point of use. It's lighter than air and will rise and diffuse in the open. Explosive concentrations can be between 5 and 15%. To stop the flow of the gas into a structure, the gas meter should be located maybe on the exterior or interior of the structure. The petcock should be rotated using a wrench or spanner from in line with the piping to where it is facing across the piping. If the meter is on fire, a wide fog pattern should be used to protect the firefighters assigned to turn off the gas. Liquid propane gas. Propane is the most commonly used as fuel gas. Stored in a liquid state under pressure, it is odorless until an odorant is added, which would be the mercaptan again. Above 1.5 times heavier than air and settles to low areas. Explosive in concentrations from 1.5 to 10%. It can be transported by buried pipelines, in cylinders, and in tanks. Unburned gas may be dissipated by fog streams of at least 100 GPM. All LPG containers can levy when exposed to flame. A supply of LPG into a structure can be stopped by shutting off the main shutoff valve at the tank. Residential water shutoff valves are located underground with the water meter. The valve should be rotated using a wrench or spanner from in line with the piping to where it is facing across the piping. With commercial buildings, the shutoff valve will require a special water valve key to shut off the water. Fire department operations in buildings with sprinkler systems. Whenever possible, pumpers supplying hose streams should operate from mains other than the supplying system. So basically meaning, if you have a fire that has its own supply system, you want to use a different hydrant that's not on the same water distribution system. Fire department connections. Usually a clapboard Siamese with at least two 2.5-inch female connections. A check valve is located between the FDC and the system to prevent water from the system flowing into the FDC. A supply pumper should have a capacity of at least 1,000 GPM to supply the FDC. Using same water main as the supplying system will rob the sprinkler system of water. Again, a minimum of 2.5-inch or larger lines should be attached to the FDC. Most sprinkler systems are supplied at 150 psi. Control indicator valves, located between the water source and the sprinkler system to shut off the water supply, and they will visually show if opened or closed. Our outside screw and yoke has a yoke on the outside with a threaded stem which controls the valve gate. The threaded stem is out of yoke when open. So currently in this picture, the valve is open. The post indicator valve, the valve stem inside of a hollow post, has a small window on the post where open or shut is displayed. A wall post indicator valve is similar to the post indicating valve but extends through the wall. Post indicator valve assembly has a side area that is open when the valve is open. Control valve should not be closed until fire has been extinguished unless the incident commander determines need to prevent further damage. If the control valve is closed, station a firefighter at the valve with communications to the officer in charge in case the valve needs to be reopened. Restoring the system to service should be done by the representatives of the owners or a commercial sprinkler service company. After a fire is under control, firefighters should control of water flow from the sprinkler heads to minimize the water damage. Wooden wedges or sprinkler tongs or other devices can be used to stop the water flow. Remove sprinkler wedge or clamp from the apparatus, raise a ladder under the activated head, insert the wedge or clamp onto the flowing head, and gently tap the wedge into place to stop the flow. You may have to use 2 wedges, one from each side, in order to completely stop the flow. It just depends on the sprinkler head itself. Our master streams are used when the fire is beyond the control of hand lines or in a location unsafe for firefighters. May be used for a direct fire attack, to back up hand lines used from the exterior, exposure protection. And the master stream must be properly positioned because it must be shut down, completely shut down to be removed. If directed into a building, the master stream should be close enough to hit the base of the fire. If used for exposure protection, the stream should provide maximum coverage. Master streams flow a minimum of 350 GPM and should be supplied with at least 2.5-inch hose lines for an adequate flow. And a minimum of 2 firefighters are needed to set up and supply water to the master. A firefighter should remain with the master stream unless it is being used in a hazardous location. Elevated master streams may be used to apply water to the upper stories of the buildings and are delivered by different types of apparatus. A quint is an apparatus equipped with a pump, water tank, and aerial device. An aerial ladder is an apparatus equipped with a hydraulically operated extension ladder, usually have a built-in waterway to supply a master stream. An aerial platform is an apparatus with the aerial device equipped with a personnel carrying platform. Aerial ladder platform combines an aerial ladder with a platform supported at the end of the ladder. An articulating aerial platform, a personnel carrying platform, is supported at the end of two or more booms hinged and operating in a folding manner. A water tower is a pumper equipped with a hydraulically operated boom dedicated to apply water which cannot be used for rescue. Suppressing Class C fires. Once de-energized, fires involving electrical equipment can be handled as appropriate for the fuel burning. Firefighters must always remember to consider any electrical equipment or wires as energized until the utility company confirms that. Class C fires may occur at power substations, commercial high voltage installations, telephone company relay switch stations, photovoltaic arrays, railroad electric engines, vehicle accidents, computer rooms, cellular company antenna stations. In some commercial and high-rise buildings, power will be needed to operate elevators and air handling equipment. The power to the entire building should not be shut down until ordered. When shut down, the main power switch should be locked out or tagged out to prevent it from being turned back on before it is safe. If locked out or tagged out devices are not available, a firefighter with a portable radio should be assigned to the switch until the power can be restored. No lockout should only be removed by the individual who placed it there and knows the power can safely be restored. Fires involving delicate electronic equipment or computer equipment should be extinguished with a carbon dioxide or halogenated agent. Using water on energized electrical equipment is inappropriate, but if absolutely necessary, it should be only used from a distance as a fog stream. Fires in ground-level transformers can be extinguished with a chemical or carbon dioxide extinguisher. Fires in pole-mounted transformers should be allowed to burn until the utility company personnel arrive with firefighters protecting any exposures. Downed power lines may start fires in ground cover. An area equal to one span between poles should be cordoned off around the break. Firefighters should wait until a ground fire burns at least one span length away from the line break before extinguishing the fire. Fires in underground electrical systems such as cableways and vaults present additional hazards. A spark or arc can ignite gases, causing an explosion. A utility manhole and vault covers can be thrown some distance from the explosion. A utility vault should never be entered by firefighters to attempt a rescue. Personnel should keep at least 300 feet from underground electric vault fires. There is a higher than normal possibility of backdraft with the utility vault fires. Carbon dioxide or dry chemical can be discharged into the utility vault and the cover be replaced. In high voltage commercial installations, some commercial and industrial facilities may have electrical equipment in excess of 600 volts. Water, even fog streams, should not be used on fires involving the high voltage installations until the utility company advises it is safe. Smoke from these fires is extremely hazardous because of the plastic insulation and coolant used, so decontamination procedures must be followed. Normal residential current can deliver a fatal shock. Electric hazards include cardiac arrest, respiratory arrest, paralysis, joint damage, arc burns to eyes, ventricular fibrillation, surface or internal burns, and involuntary muscle contractions. The seriousness of an electrical shock depends on the electrical path through the body, the degree of skin resistance, wet, which will be low, or dry, which is high, the length of exposure, available current or amperage flow, available voltage, and the frequency, whether AC or DC current. Assume all electrical wires and devices are energized until proven otherwise. You want to establish an exclusion zone equal to one span in all directions from down power lines. Wires may have been weakened by a short circuit and may fail at any time. Use only tested and approved tools when insulated with insulated handles. Guard against electrical shocks, burns, and eye injuries from arcs. Wait for utility workers to cut any power lines. Use caution when with ladders around power lines, and do not touch any vehicle in contact with the power lines. Jump clear of any apparatus keeping both feet together that may be in contact with electrical lines. Do not use solid or straight streams on energized electrical equipment. And beware that fences and guardrails can be energized by down power lines. If wires are down and there is any tingling sensation in the feet, back away. Avoid ground gradient hazards by maintaining a safety zone around the down lines. Ground gradient is produced when current from down lines passes along the ground. Current flows outward in concentric circles from the point of contact. Walking normally through a gradient area is dangerous because of the difference in electrical potential between the feet and the ground. To back out of a gradient area, keep both feet in contact with each other and hop or shuffle out of the affected area. Class D combustible metal fires can produce extreme temperatures and water. Water is only effective on combustible metal fires when attempting to cool the metal below its ignition temperature. Directing water onto the burning materials can result in a violent decomposition of the water and release of gas. The best strategy may be to protect exposures and allow the metal to burn itself out. Special extinguishing agents may be shoveled or sprayed from extinguisher to try to cover the burning. An ash layer may cover the burning material and give the impression the fire is out, but there may be an extended period before the metal cools to save levels. Combustible metal fires may be greater than 2,000 degrees Fahrenheit even after they appear to be out. Fires in single-passenger vehicles are some of the most common types of fires we encounter. Vehicle fires should be treated with the same caution as structure. Additional hazards with vehicle fires: the traffic, reduced water supply, the unknown contents, and the instability of the vehicles, or interior plastics, and weakened piping. The pressurized shock absorber bumpers. When heated, these can explode and throw the bumper a considerable distance. They may explode after a fire has been knocked down, and the personnel must avoid working in front or behind the vehicle. Struts used to support the truck lid, hatch, or hood can be launched from the vehicle or opened with extreme force. The airbags, hollow drive shaft and hatchback supports, pressurized natural gas or LPG tanks, alternative fuel tanks, ammunition or fireworks, illegal drug or other chemicals, and a minimum of 1.5-inch line should be used with the backup line deployed as soon as possible. Position your apparatus uphill and upwind, and full protective clothing including SCBA are required, and hose line should be placed between the vehicle and any exposures. You want to attack the fire from a 45-degree angle to the long axis of the vehicle. Extinguish the fire on ground, around and under before moving into the vehicle. The fire should be attacked from a distance with a straight stream and then approach using a medium to wide fog. For engine compartment fires, the fire must be knocked down before the hood can be opened. You want to direct the fire stream through the grill, and a piercing nozzle can be used through the hood, fenders, or wheel wells. Firefighters can make an opening between the hood and the fender with a prying tool and then use a narrow fog stream. For passenger compartment fires, the vehicle should be approached from the front or rear corner with a wide fog stream. A medium fog stream should be used in a circular motion into the interior. For undercarriage fires, you want to use a straight stream from a distance by bouncing the stream off the pavement under the vehicle onto the undercarriage. By opening the hood and directing the stream through the engine compartment. For alternative fuel vehicles, which could include natural gas, LPG, electric or hybrid electric, ethanol or methanol, biodiesel, or hydrogen vehicles. There are no requirements that alternative fuel vehicles be marked for the type of fuel and may be no visual indicators present. Manufacturers may mark the vehicles with vehicle logos, fuel-specific logos, special fuel ports, or distinctive vehicle profiles. Additional considerations when dealing with alternative fuel vehicles. You want to approach from upwind and uphill at all possible. Approach from a 45-degree angle to the vehicle. Wear full PPE including SCBA. Use non-sparking electrician tools. Do not use flares. Deploy a backup line. Use an extinguishing agent specific to the fuel or battery pack. Compressed natural gas or liquefied natural gas is clean burning, high ignition temperature above 1163 degrees Fahrenheit. Flammability range is approximately 5 to 15%. It is non-toxic and non-corrosive. It is lighter than air. is stored under pressure and will have a visible flame. A CNG or LNG diamond logo may be placed on the vehicle. Fuel tanks may be in trunks, under side panels, or on open trunk bed, and it is stored under high pressure. If no fire is visible, use a gas detector to detect any leaks. Remain clear of any vapor clouds. If fire is visible, allow the fuel to burn itself out and use water or foam if necessary. You want to use fog streams to disperse vapor clouds. LNG is stored as a liquid below 260 degrees Fahrenheit. Below negative 260 degrees Fahrenheit, that is. Frost on tank may indicate tank failure. Avoid contact with LNG. Shut off the ignition. If there is no fire, shut off the gas cylinder valve handle. Use a dry chemical or high expansion foam on the surface of an LNG fire. In Seattle, a CNG Honda Civic incendiary fire with an explosion. LPG is the third most common vehicle fuel following gasoline and diesel. It is clean burning, safer than gasoline, colorless and odorless, and is stored under pressure. LPG vehicle tanks can levy when exposed to heat. Tactics for LPG-fueled vehicles. As always, approach only from a 45-degree angle to the vehicle. Use a gas detector to check for any leaks if there is no fire. If on fire, allow the fire to burn itself out. And use foam or water only if necessary. Direct your fire streams at the top of the LPG tanks for cooling, and stay clear of any vapor clouds. Hybrid or electrical vehicles should have visual indicators such as a vehicle name, logo, charging port, or distinctive profile. The batteries may be in the engine compartment, trunk area, or under the vehicle. There may be no noise when the engine is running. Electric vehicles operate only on high voltage batteries which must be charged. Hybrid vehicles operate from gasoline and high voltage batteries. Fires confined to the cabin or trunk can be extinguished using tactics associated with conventional vehicles. Orange-colored cables and components contain high voltage electrical power, and firefighters must avoid contact with any orange electrical cables and components that have high voltage. If a fire has burned the warning labels or rendered them otherwise ineligible, firefighters should not touch any electrical drive or drive system component. Firefighters should never attempt to breach a high voltage battery or its casing for any reason. Many high voltage components are directly accessible from the engine compartment, and applying a fog stream defensively through the existing openings in the wheel wells and grill can be done safely to knock down the fire. Firefighters should not attempt to force entry into the engine compartment with prying tools, spike or cut the hood or fenders with a piercing nozzle, cutting tool, or prying tool, or perform any of these tasks could result in a severe shock or electrocution. If a hybrid vehicle fire is well involved, large amounts of water should be used. Large amounts of water will not be able to directly attack a fire burning inside the battery pack unit itself. Burning batteries will produce large amount of hydrogen, increasing the fire intensity. Apply sufficient quantities of water to the batteries to cool the metal housing of the battery pack and control the fire until the battery modules that are actually on fire burn themselves out. Avoid contact with any high voltage component during the overhaul. Never attempt to cut, breach, or remove the high voltage battery or any high voltage component. Care must be exercised before manipulating the vehicle in any way with any forcible controls. Ethanol or methanol fuels are gasoline blends. Ethanol and methanol fires burn bright blue and are hard to see in daylight. A thermal imager may be necessary to see the flames. An alcohol-resistant foam should be used for fire extinguishment. Biodiesel is a blended liquid made from plants and diesel fuel. A yellow liquid with the odor of cooking oil can be used in any diesel vehicle. Firefighting tactics are the same as vehicle. Hydrogen-fueled vehicles are becoming more common. They are odorless, colorless, self-ignition temperature of 550 degrees, and a flammability range of 4 to 75%. The hydrogen-fueled vehicles have a vented fuel tank in the trunk. Flames are visible and a thermal imager may be necessary, flames are invisible and a thermal imager may be necessary to view the flames. If on fire, do not attempt to extinguish, protect your exposures, and allow the fuel to burn off. Exterior fires in small structures, stacked materials, and trash containers can endanger exposures. Stacked and piled combustible materials may be at lumber yards or manufacturing facilities, bales of cardboard at retail outlets, baled or rolled hay on farms, baled materials at recycling facilities. The goal should be to confine a fire to the pile or building of origin. A straight stream should be directed at the edge of the fire. And when the fire is reduced, fog stream should be used. Pike poles and hay hooks should be used to pull the materials apart while being wet down. Machinery such as a backhoe can be used to break large. Small unattached structures such as storage sheds, outhouses, and pump houses should be attacked from the exterior and prevent fire spread to enclosures. Storage sheds may contain chemicals, flammable, combustible liquids, compressed gas cylinders, aerosol cans, other explosive, and illegal materials. The volume of smoke and fire and the color of the smoke may indicate the material is burning. If the hazard is unknown, the fire should be attacked with a straight stream from a For dumpster and trash container fires, be aware of the possibility of dangerous combustion byproducts. Hazardous materials, plastics, flammable combustible liquids, biological hazards, gas cylinders, aerosol cans. On December 29, 2009, an explosion that killed Santa Ana, Wisconsin firefighter Steve Kesser and injured 8 others was caused when a firefighter sprayed water and foam into a burning trash bin. The trash bin contained aluminum alloy shavings and 55-gallon steel barrels of aluminum slag. Full protective clothing and SCBA must always be used if it is necessary to approach the container. Size of fire stream should be determined by size of the container and exposures. Check exposures for extension, cool from a distance with a straight stream before approaching, and overhaul to prevent rekindle. Some departments prefer to use a master stream to flood the container. Can create containment problems if the water used becomes contaminated with hazardous substances from the container. Between 1990 and 2013, 417 firefighters have died fighting wildland fires in the U.S. An average of 7 million acres of wildland burn each year and 70,000 fires in the U.S. Ground cover fires may be caused by lightning strikes, auto-ignition, intentional acts, campfires, smoking materials, machinery, power lines, or electric fences. They may be classified by type and location of the fuel. The ground fire burn in a layer of dead organic materials which cover the soil in forested areas. It can be slow, smoldering fires which may go undetected for months before flaming, usually limited to forests and difficult to extinguish. Surface fire, the most common type of ground cover fire, involves grass, shrubs, and other vegetation and can occur anywhere, and can be natural or human caused. A crown or canopy fire is a wind-driven, high-intensity fire through the treetops, caused by lightning strikes or extension from surface fires. Extensions from surface fires are called ladder fires because the fire spreads upward through small trees. The fuel is classified by grouping those with similar burning characteristics. Subsurface fuels, the roots, peat, and partially decomposed materials that are under the ground surface. Surface fuels, twigs, grass, brush, crops, logs, and heavy limbs on the ground surface. Aerial fuels, suspended and upright fuels such as snags, leaves, branches, and brush over 6 foot. The burning characteristics of fuels can be affected by the fuel size. The smaller fuels burn faster than larger ones. Fuel compactness, tightly packed fuels burn slower than those loosely piled. Continuity, fire spreads faster in fuels closer together. The volume, the amount of fuel influences a fire's intensity. And fuel moisture content, the drier fuels ignite easier and burn more intensely. The weather affecting wildland fire behavior. The wind fans flames and supplies fresh air to the fire and affects direction of the spread. The temperature has effects of wind and closely related to humidity primarily affects the drying of the fuel. Relative humidity affects moisture content of dead fuels. Precipitation determines the moisture content of live fuels. The effects due to topography. The steeper the slope, the faster the fire will travel. The aspect, the wildland fires usually burn faster on southern exposures. Local terrain features, obstructions such as ridges, trees, and bluffs may alter airflow and fire behavior. Wind restrictions, the drainage, sinkholes, or depressions can create updrafts causing a chimney effect. Parts of a ground cover fire. Any natural cover fire will contain at least 2. A head, which is part that spreads most rapidly. usually on side opposite from the wind direction. It burns intensely and usually does the most damage, and the head must be controlled to contain the fire. Fingers, long narrow strips extending from the main fire. If not controlled, fingers can become new heads. The perimeter, outer boundary or distance around the outside edge of the fire, also called the fire edge. The rear or heel, side opposite the head, usually burns slowly and is easier to control than the head. It burns downhill or against the wind. Flanks, sides of the fire, fingers form from the flanks. A wind change can change a finger into a head. Islands, unburned areas inside the fire perimeter. Spot fires are caused by flying sparks and embers. Could trap firefighters between fires and must quickly be extinguished or will form a new head and grow. The green, the area of unburned fuels next to the involved area, not necessarily a safe area, simply is the opposite of the unburned area. Opposite of the burned area. The black is the area where the fire is consumed or and your black area is typically going to be your safest area. Wildland protective clothing and equipment. Standard structural firefighting protective clothing is inappropriate and can be dangerous in wildland situations. You should have a helmet with eye protection and a neck shroud, protective footwear, and flame retardant shirt and pants or a jumpsuit. Traditional firefighting gear can be very big and bulky. Wildland firefighting procedures. A control line or perimeter can be made at the burning edge of the fire next to the edge of the way. Direct attack on the flames at the edge or closely parallel. An indirect attack, attempt to cut off the progress of the fire. Establish fire breaks that completely surround the fire area. Burn off or remove fuel between the fire break and the body of the fire. Fire is indirectly controlled by allowing the body of the fire to consume fuel up to the fire break. Assign personnel to check and extinguish spot fires outside of the fire. And the most important consideration in any ground cover fire is life safety, as with anything else. Safety begins with the proper size up, the fire location, the fire type, the incident access, our exposures, weather conditions, wind direction and speed, our topography, the visibility, and our resources available. Situational awareness can be effective using the LCES concept. L for lookout. Lookouts monitor fire development and spread. C, the communications. Every person operating at the incident must be in communications with the incident commander. Rapid communications can prevent personnel from becoming trapped by changes. E, for escape routes. Personnel near the fire line must work from the burned side and always have an escape route available. S, for safety zones, should be in the burned area if cooled and accessible. Ten standard firefighting orders. 1. Keep informed on fire weather conditions and forecast. 2. Know what your fire is doing at all times. 3. Base all actions on current and expected behavior of the fire. 4. Identify escape routes and safety zones and make them known. 5. Post lookouts when there is possible danger. 6. Be alert, keep calm, think clearly, and act decisively. Maintain prompt communications with your forces, your supervisor, and adjoining forces. Give clear instructions and ensure they are understood. Maintain control of your forces at all times. And 10. Fight fire aggressively first. Non-fire hazards may be encountered during ground cover fire operations. Unstable tree hazards created by weakened trees from age or fire. Animals that have escaped the fire may be found in caves and confined spaces. Electrified fences have killed and injured firefighters. And electrical power lines may have fallen during the fire and explosives may be found around military areas or construction sites. Hazardous materials from storage tanks or storage buildings. Rolling or falling debris. Pits or shafts covered by loose debris. Animal traps may be hidden under brush. Intentionally set booby traps set to protect illegal activities such as meth labs or marijuana growing operations. Lightning hazards. Watch for weather changes. Do not stand under tall, isolated trees. Stand away from open water, metal objects, or wire fences. Situational awareness on the fire ground is dependent on the communications between firefighters. Everyone must continually watch out for their own safety and the safety of everyone else. The first arriving engine and a structure fire should initiate incident command and the fire attack. If smoke or fire is visible on arrival, this engine may stop and lower the line. The first arriving company officer should conduct a rapid initial assessment. Are rescues needed immediately? Are only the contents, or is the structure burning? Are exposures threatened? Are there sufficient resources on the scene or en route to handle the situation? If additional resources are going to be needed, the officer should immediately call for them. If an immediate rescue is needed, it may be done even before there is enough firefighters on scene to form a rapid intervention crew. Fire departments must follow the 2-in, 2-out rule whenever firefighters must enter a structure for a fire attack or rescue. If there are not personnel available to follow this rule, no one should enter a structure until more personnel. If there is a known life at risk which can be saved without undue risk to the firefighters, it may be necessary for a 2-person team to enter with only one outside for an emergency. This decision should be made by the initial incident commander based on department policies in the specific situation. If the fire is threatening to extend to a nearby structure, lines may be pulled to protect the exposure. With a small room and contents fire, the officer should transmit a radio report confirming the exact location, the conditions at the scene, and if additional resources are needed. Once the fire's location is known, the first attack line should be placed to protect the trapped victims and the rescuers, protect the primary means of egress, protect the interior and exterior exposures, and begin extinguishment. The second arriving engine should establish an adequate water supply, unless otherwise assigned. Once water supply is established, this crew should back up the first attack crew, protect the secondary means of egress, assist in extinguishment, assist in fireground. A support company, a truck or rescue company, may arrive after the first engine and should be responsible for the forcible entry and ventilation, search and rescue, the ladder placement, salvage and overhaul, setting up lighting equipment, controlling utilities, checking for extensions, and overhaul. A support company may use a master stream in a blitz attack. Must be coordinated with other operations to prevent injuries. Interior attack teams may be injured by a steam or forced to retreat by poorly directed outside master streams. A rapid intervention crew, it is not possible to predict when an emergency can happen on the fire ground by trapped firefighters, equipment failure, or explosion. A rapid intervention crew should be in place and ready should they be needed to assist other personnel. At least 2 firefighters should be ready in full protective equipment with the equipment and tools to. A RIT is not to perform any other assignments. Individual team members may be assigned minor scene duties but must be able to deploy if immediately needed. More than one rapid intervention crew may be established based on the size of the incident and the number of emergency workers in the hazard area. Not to be used for rescue of victims, only the emergency workers. The team must be equipped with full PPE and SCBA, a radio, forcible entry tools, any special rescue tools needed, a spare SCBA or air cylinder, rescue ropes, hand lights, and a thermal imager. The RIT must report to the incident commander and might prepare for their operations by staging their equipment, determining the possible paths for emergency egress, completing a 360-degree survey, removing egress barriers, monitoring radio traffic for a mayday, placing ladders, and opening exits. After arriving on the scene, a chief officer may assume command from the original incident commander. If the incident is well organized and progressing well, the chief officer may choose to assume another role in the command system. The first arriving fire officer or firefighter must establish command and transfer command when appropriate. A nothing showing investigation mode. On arrival, there is no obvious problem found. The incident commander will advise by radio that nothing is showing, directs the responding units where to stage near the scene, accompanies unit personnel on an investigation of the situation. The fast attack mode. If the officer or firefighter must initially become directly involved with the situation, he or she should assume command and announce that the unit is starting a fast. The fast attack continues until the incident is stabilized. The incident is not stabilized and the EIC must withdraw and establish a command post. If only the IC and other firefighter in the hazard area and one must leave, both must leave. Command is transferred to another individual. Also be known as combat command or a working command. A formal command involves the first arriving officer or firefighter assuming command, names the incident, remains at the apparatus and designates the incident command post, assigns units and personnel to functions to control the incident, may appoint one unit member to supervise the rest of the unit, may assign unit members to work under another company officer, or may use unit members to perform staff functions in the support of command. When transferring command to another officer, the transfer must be done face-to-face or over the radio. Command must never be transferred to someone who is not on the scene. The current incident commander briefs the new commander on the name of the incident status, safety considerations, goals and objectives in the incident action plan, deployed resources and their assignments, and the need for additional resources. Fires in underground spaces. Firefighting may sometimes be necessary in locations below grade or without natural or forced ventilation. It could be underground vaults, caves, sewers, storage tanks, trenches. Firefighters must remember to recognize the inherent hazards of confined spaces: oxygen deficiencies, flammable gases or vapors, toxic gases, extreme temperatures, explosive dusts, limited means of egress, cave-ins or unstable support members, standing and utility hazards. Facility personnel can be of great assistance at the scene because of their knowledge of the facility and the probable location of the fire. Pre-incident planning should be conducted of existing confined spaces where emergencies may occur to familiarize personnel with the facilities. The command post and staging areas must be established outside of the hot zone. Personnel must be tracked entering and leaving the confined space. Fire may be indirectly attacked using penetrating nozzles or distributor nozzles. And due to ventilation problems, firefighters will tire more quickly and consume air faster than normal. Class B fires. Extra caution is needed when attacking Class B fires. Avoid standing in pools of fuel or runoff water. Protective clothing can absorb fuel and burn. Approach from uphill and upwind. And all ignition sources and the leak controlled. Unless the leaking product can be turned off, fires burning around the relief valves or piping should not be extinguished. Never assume that relief valves are sufficient to safely relieve pressures under fire conditions. An increase in relief valve fires or in sound may indicate failure. The sudden release of vaporization of liquid can result in a tank rupture. This is called a BLEVE. It is boiling liquid expanding vapor. Result in the explosive release of pressure, fragmentation of the container, and a large fireball. It occurs when flames impinge the tank shell above the liquid level. Water should be applied to the tank's upper portion from unattended master streams. Most fixed facilities containing Class B liquids or gases are protected by fixed fire suppression systems. Some of these systems pose special hazards to personnel. If a carbon dioxide flooding system has been discharged, the oxygen will be depleted, and poor visibility can result during a activation as well. Foam suppression systems may be installed where large amounts of Class B liquids are used or stored. Some of these systems will require fire department support. If the system is activated, a foam blanket must not be disturbed. Total flooding systems are installed in aircraft hangars and transformer vaults. When activated, the system fills the area with foam until the fire is extinguished. The foam blanket should not be disturbed. A non-water-based system may be installed in industrial occupancies where electronic equipment is located or maintenance facilities. If these systems have been activated, the extinguishing agent should not be disturbed until it is determined the fire is extinguished. An SCBA is necessary when working in these areas. Hose lines should be in place to extinguish fires and adjacent to class. using water to suppress Class B fires, to cool exposures in storage tanks, to remove fuels to areas where they can safely burn and can be more easily controlled, to dissipate flammable vapors, and to displace fuel from pipes or leaking tanks. As a protective cover for crews advancing to shut off the flow of the fuel, 2 hose lines should be used with slow, coordinated movements. A minimum of 500 GPM must be applied to the tanks at points. Straight stream should be applied to the top of the tank to run down the sides. As the lines are advanced, the streams are widened to a fog pattern to protect the crews. The fog pattern should overlap with no open space between them, which could allow flames to come through. The techniques for approaching and controlling bulk transport vehicles fires are tanks. With additional hazards such as the risk from traffic, reduced water supply, difficulty in containing spills and runoff, weakened tanks from collisions, and vehicle instability, and failures of tires can cause a load to shift. The type of cargo should be determined as soon as possible. At least one lane of traffic, in addition to the incident lane, should be closed. Whenever possible, approach from upwind. Flammable gas leaks. Contact the utility or pipeline company immediately for assistance. All vehicles should approach and stage on the upwind side. The area around the leak and downwind should be evacuated. Eliminate all ignition sources. Surrounding areas and buildings should be checked for gas. Firefighters must never attempt to operate pipeline valves, which could worsen the situation. If gas is burning, it should not be extinguished. An unburned gas could flow to other areas. Use streams to protect exposures. Flammable gas tanks and cylinders with relief valve operation should not be approached. If the relief valve is operating, the tank is under stress. The relief valve sound increases, an explosion could be imminent, and evacuation must be ordered. Cool upper vapor portion of vessel from the maximum distance until the relief valve resets. Wearing full PPE, 2 teams of firefighters using a minimum of 2 1.5-inch lines should advance using wide overlapping fog patterns. All tanks must be approached from the upwind side and from sides of the tank. Personnel must be on the inside of the lines with the leader between the nozzle operators. Water must be kept on the vessel at all times. When the cylinder is reached, the nozzle teams should isolate the shutoff valve from the fire with the fog streams. Without breaking the stream patterns, the team leader should then close the valve to shut off the fuel. Firefighters should continue to apply water to cool the tank after the burning is extinguished. With streams still flowing on the tank, personnel should back out. The tactics of the firefighters on the initial fire attack team determine the success or the failure of the fire control operations. Fire attack must be coordinated with rescue operations, forcible entry, ventilation, and utility control. The life safety is always the first and most important tactical priority regardless of the situation. In any fire situation, coordination between different crews performing different functions is essential for and that is our fire control chapter. Thank you for tuning in.